Yeah. So there's a whole bunch of stuff you have to stop saying. So like a method is an OO thing, right? Because it's attached to an object. So you don't have you can certainly have the concept of an object, but it wouldn't generally have methods attached to it. That would
they're purely for data and functional, correct?
Yeah, but you could attach functions to that object. That would be fine.
Okay.
You can have an object which holds a bunch of functions, and those functions could even be like and they could be curried functions and partially applied with some of those objects, or objects could be held inside the functions. So it's quite interesting. But you stop saying methods, you say functions, and you stop saying variables, you say values. Those are like the two of the changes you may have to reprogram your brain. But the cool thing is those things port back to OO as well, because OO has got functions. Methods are just functions, right?
Yeah.
And values are generally like a const var or like a const or something in some other language, right? And generally you should be using consts more than vars everywhere. As much as you can in OO, right? You should be trying to const everything. It's just good practice, right? The immutable data structures is a good practice even in OO. I think. I don't know. I think so. Paul, how's it? Check he's still in Prague. How's it?
Morning. Yeah, it's pretty sad that my most recent exciting pick is from 2 years ago.
Sorry, man. Is that Vitalik in the background? No, it's not.
No.
Just some random guy, a security guard.
We can't have that picture. That's way too awkward. The most awkward photo ever.
Yeah, that was a very horrible picture. That was fun. All right, good. I don't know if there's anyone else, but let's dive into stuff. So, oh wait, I'm gonna share my screen. That's what I've forgotten to do. So you missed last time, Paul, but that's fine. You will catch up. And this is not a lecture. It's very interactive, which was super cool. So last time we went through a bunch of stuff and we asked a bunch of questions and just tried to like explore stuff. And so PureScript is just as a reminder, PureScript is a pure functional language. It's very inspired by Haskell. There's a bunch of differences between what a pure functional language is versus what a regular functional language or an impure one. And we talked through a couple of things. Let me see. I haven't really touched anything here. I did clean some things a little bit. We talked about pure language is strictly typed, but it's also implicitly typed. So that means you can leave off types and the compiler will figure them out. So things like immutable. So random is not pure. We talked about lists and arrays. That was quite fun. Oh yeah. So what we wanted to continue with, actually, I think I did notice. So I think it was me and Bhavesh and Miguel at the end of the last thing talked about this. We were building this example where we said, hey, we've got, I think there's a bunch of crap in here, but like, look at that line there. We've got result equals filter. And remember, we've got X. X is a list of ints. So let's just go spago REPL here. And we can do this ourselves. Oops. Oh, it won't let me do that because there's a compile issue here. I'll just fix it. I think I know what the issue is. Oh, let me just compile it out so that it works. Yeah. We were saying, so if we want to create this little range thing, we're going to import data.list, right? So we got the range function. We can go range 1,10, 1 space 10. It invokes the range function. That's going to return us a range from 1 to 10. So it's inclusive on both sides. So that's what X is. And if we hover over it, it's a list of int. That makes sense. Then ignoring all this junk over here, we were wanting to take that list of X and filter it for all of the even numbers. So this is like our little anonymous function, which I think you would call a predicate, right? I think it's a predicate in most other languages. So it's like a little anonymous function that for every element, so filter obviously the first function that filter takes is a function returning a Boolean. So for every element, tell me, do you want it in the final list, yes or no? And so we're saying we only want the ones that are even, right? So where it the modulus of 2 of that element equals 0, that tells us if it's even. You agree? And this is what Bhavesh and Miguel and I like kind of figured out, because we found a function called mod from somewhere. Oh yeah, mod just exists, so we can go mod. We can go mod like 1, 2 or something, and it gives us 1, right? So we can say mod like is 5 even. So we can say mod 5 of 2, and it would say 1. And if we go naught equals, would that be right? So mod, yes, equals 0, and it's false. So the 5 is not even, whereas 4 would be even. You agree? So we found this cool function called mod. We were expecting, because of other languages, to like use the % sign. So what we did is we said, okay, well, we got mod, and then we figured out how we can redefine mod as like as an infix operator. So in PureScript, you can go infix r. This thing is the precedence of that thing. So this function mod as % will turn % into an infix operator for us. And I think it's infix r because it's on the right side, so it's like left to right or something. I'm not sure. I assume that there's an infix l. Infix l, I don't know. Mod as %, or as that. Yeah, and it's like, okay, that's also fine. So we can create a new operator called %hat, which is infix left. I don't know. Infix r seems right. And then we figured out that this number here is the precedence. So what you can certainly do in in PureScript or Haskell is you can take any function, so say like the mod function, and you can backtick it, which will automatically convert it into an infix function. So as long as it's a function that takes 2 arguments and returns something that is infixable, because like left and right, you can backtick it. So that's what we did up here. We said, oh, cool, we've defined our own function called ++, which takes x and y, and it returns x plus y. And then we said we could use it like this. So 1 backtick ++ and then something. And that would be fine. So y then ++ gets invoked. And then we even said, hey, like, why don't we infix r that ++ as ++, and then you could use it in the same way. So you could go ++. So this was definitely a rabbit hole down infix functions and operators and stuff. Interestingly, so I'm going to kill all of this stuff because that's all kind of recap. Is we've still got a little error here, and it's like saying could not match int with type boolean. And I think so if I look at this, it's probably because we've made the precedence super low. So what's happening is like that side is resolving first. So it's saying, because I reckon if we bracket this off like that, our error goes away, right? Yeah, it does. So now we just get a warning that result is not of type list int. That should kill our warning. So like that would be where we would change the precedence probably, and we'd say actually like mod probably has a higher precedence than equals, right? And then we wouldn't need to bracket like this, because I think in most, like if I think about, I'm not going to go down that rabbit hole, but so what we could do is we can just like control click on equals, and we can go and have a look at how equals is defined and like check it out. It's like, oh, it's an infix function with a precedence of 4 set to this function called eq, I don't know, as that, and you can see, oh, its precedence is 4. So probably if we set our precedence to 5, make it just slightly stronger, our error goes away. So that's awesome, right? So that's a pretty cool, like what I love about Haskell and PureScript is this ability. You must just go and read the standard library. Like if you like even equals, that's defined as something in some library called eq.pers, right? And there it is. And if you wanted to understand what is EQ, you could click on that and you can go, oh, look, EQ is a function given 2 thingamabobbies, like A and A, 2 of the, so when you read this, who remembers what this means? The A arrow A. Like, what does that actually mean? Because you would expect a function should have like types here, right? So what are these types? Who wants to answer that one? It's a good warm up.
They're generics, right?
Yeah. So you can consider them like you would a generic thing in C# or Java or C++ or whatever that has generics. Yeah. So a lowercase letter. So what you'll notice is like there's like the kind of the main like built-in types. I suppose you could call them built-in types. We'll see that actually they're not that built-in. Tend to have capital letters. So anything with a capital letter is like an actual type, whereas lowercase letters are I don't actually know what you call them, like types of types. But like the word generic is exactly right. So you would expect to, in another language you might see this T thing or whatever. And that would be more considered a generic. This is, check, I'm actually editing eq dot or eq dot PureScript, which is bad. I shouldn't do that. But yeah, it's a generic type. So it means that equality can be between any two things, but as long as they're of the same type, because it's like A goes to A. So it's like if it's an int, then it's an int here and an int here. If it's a double, then it's a double here and a double here. If it's a string, it's a string here and a string here. It's not like they can't vary because A is here and A is there again. So it must be the same A. If it was A to B, that would tell me that the types can vary between these two parameters. So it could be like an int to a string or something. And that would be weird because you couldn't compare equality between an int and a string. Like that doesn't make sense, right? So when you're comparing equality, it's always things of the same type, right? And so that tells you a lot, just by seeing the A arrow A Boolean, you go, oh yes, of course. Equality is only between things of the same type. And that's like very nice and like explicit, I suppose. So we'll come back to what this class thing means maybe one day. This is this is very interesting. This is where functional languages effectively derive their like polymorphism equivalent is through this thing called classes. And so what you can imagine here is you can say like, yeah, but where is the actual definition of where we compare an int to an int? And it's like, oh, that would be implemented as an instance of this class, if that makes sense. But well, and if you scroll down a little bit, it's like, oh, look, there's an instance of int eq, which like you could read this in OO is like, oh, it inherits from eq of type int. So where it's setting a to an int, and then it implements it here into eq int impl, which I can't jump into, which I'm not sure why. But like that's we'll get back to this. And this is kind of just like how OO kind of does polymorphism, in some kind of way. It's where you build these like a higher level operations. Okay. Any questions on like this or on Wednesday's stuff before we carry on with Terence's example? I'm calling this Terence's example. I hope you don't mind, Terence.
No, that's great. I think I need to. I'm not 100% sure on this precedence thing with the infix, but
okay.
I'm happy to read about that on my own. I don't want to hold anything back.
No, so very simply, like precedence. Are you not comfortable with the concept of precedence?
Yeah, so I get the infix like thing, but
yes. Okay, so what does precedence mean? It's actually very simple. You get it immediately. If I've got the statement A equals A times B plus C. Sorry, this shouldn't be A. Let's make this X. Just like that. Precedence means what happens first. Does the multiplication happen first or the addition happen first? Because like if you think about it, it's either, and like this is high school maths, right? Remember we had to remember that little rhyme, bodmas or bomdas or whatever you want to call it. It's like we had to remember as high school students which operation happens first, the multiplication or the addition in that example. So I think it was brackets first, obviously, and then and then multiplication, division, addition, and subtraction. Does that make sense? Yeah. So we know that if we just look at that, we know that the multiplication happens first, right? So this multiplication has a higher precedence than addition. That's as simple as it is. So and so exactly the same thing is true. So we know that about maths, and that's cool. But if we were doing functions, so if we were going like we want to go, I want to mod that thing, and then I want to like whatever rabbit hole this thing. You have the compiler's got exactly the same problem. It needs to go, oh shucks, which side do I do first? Do I execute this first and pass that as the second parameter to mod, or do I execute that first and pass that as the first parameter to rabbit hole? Do you know what I mean? So the way we do that is we define the precedence as a number between 1 and 10. So the compiler goes, oh, I know exactly. So it just orders the operators by the same precedence. I think if we make them the same, we'll actually get an error. So for example, that little mod thing that we did there, remember we said the precedence of equals was 4. So what if we set this to 4? I actually think that will give us an error. Oh, it doesn't like this, first of all. Of course. Yeah, so we get an error here saying cannot parse an expression that uses operators of the same precedence but mixed associativity. Oh, okay, that's probably what the R means, associative. I don't know. Anyway, I mean, does that answer it? I think that
Yeah, that explains it. Thanks.
Pretty simple. Yeah. So precedence is just that. It's like, which side does it bracket? Because, and actually it's an infix problem, I think, because if we were writing this as not using infix, we would have been explicit about, we would have gone mod of that with the result of this would be like, it would be like that. It would have been like that without the infix. And I think now you would have to be pretty clear about what is bracketed here. You would have to have done this. Do you know what I mean? And so you would have been explicit that mod actually happens first and then rabbit hole happens second. Do you know what I mean? That makes sense. So it's an infix problem. It's only when you infix do you have to think about precedence, because you would naturally bracket things when you weren't doing it in infix. Anyway, whatever. Any other questions? No. Okay, so what I'm going to do is I'm going to chuck that out and we're going to infix the mod here so that we don't have the funny operator thingy happening anymore. And then I think what we were going to do is, let's write a function that does this. So maybe I like Terence's example. So we're taking a list of ints. We're going to filter them for even numbers, right? And then maybe what we should do is we should like sum them up or something, right? So we want to kind of make this a function. So let's make it more of a function, and then see how ugly we can do it. And then maybe like some methods of like trying to clean it up potentially, right? So let's like write this naively. Like here we have, this is not a function. This is just result as an answer, and it's invoking filter. But so let's make a function. I don't know what to call this. We'll call this as tfunc because it's Terence's function, right? This thing is, so it's a good idea to maybe write the signature first. I don't know if we should. Yeah, why not? So we'll say the tfunc as its first parameter. What does it take? So in this function, we want to take a list of ints potentially, and we want to filter them for even numbers, and then add them up, right? And then we sum them or something. Yeah. So what is its first parameter as the like what does it take? This function. Anybody? Drickus. I'm calling on Drickus.
List of ints.
A list of ints. Check it, you man. So we go list int, and does it take anything else?
List of ints, and then just int as the final answer.
As the result. Yeah. Cool. I think it seems good. So how do we do it? So we go, so now that's the definition, that's fine. Now we're going to implement it. We're going to say, well, what should we call it? The ints. Is that too confusing? Should we call it X? Also confusing. List underscore ints. Is that better? I don't know. Let's call it that, right? List of ints. So then we can take our cool filter thingy, and we can even take our cool little mod thingy. We can paste it underneath here. I always prefer a tab of, I don't mind tabs or spaces, but what I don't like is, how do I change my tab size? Anyone know? Spaces too, that's.
There's a thing at the bottom. If you click on that spaces too, that should.
I want to just change my tabs. Convert into tabs, indent using tab. When does it ask me for the size?
When you click on tabs or spaces. Yeah.
Indent using tabs. Oh, I see. Yes. Okay. Indent using spaces and 4. Why 2? For unblind people like me. Okay. So here's our function actually. So we're just going to say tfunc list of ints equals filter, which we've got. And we're going to use that cool thing and then, oh yeah, we should probably pass it the list of ints, right? Doesn't like this. Could not match type. List of int with type int. Why? What's our
You
issue
need
here?
to sum it first.
Oh,
So
yes.
that's still a list of ints.
Freaking legendary, right? So what does sum do? Well, let's find if there is a sum. I'm pretty sure there's something called sum. I would hope that there's a thing called sum. So look, these things take semi-rings. We'll talk about these things. This is in programming, certainly in Haskell, and I can see this now in PureScript, there's this thing called category theory, which you guys all know, right? You all know category theory, or no? I assume that means yes. So you guys all know category theory, obviously. So
Just
semi-ring
a bit
is
of
just
math.
so semi-ring is just a category. I mean, we all understand that, right? So probably we would find this in Matt's. I remember last time Matt talked about data.list, right? And we found that filter was in data.list directly because it's like a list implementation of sum. So let's see if we can find sum in here. Oh, we can't. That's so annoying. Sum? Come on. There isn't. Really? So for all foldable f, semi-ring of a, f of a to an a. So this is a functor thingy. This could be doable. We could fold. That would give us a sum. I would just love to find like something that takes a, sorry, we've got to make this right. List of int goes to an int. What is that? Oh, the length, that makes sense. Fold digits. Length, degree, head, last. From enum, generic to int hash. No kind of summy thing here. Shall we fold it? Anyone keen to fold stuff? Could be complicated for now. How would we sum ints, man? Surely sum ints PureScript. Let's just Google it. There's got to be a simple way here. I think we might be getting it out of. So let's just do the foldable one. I think it will just work, but without us necessarily knowing what this means. I don't think we will have to, but let's try. So data.foldable, foldable traversable. I wonder if we've got that package. I don't know. We'll just try it. So we're going to take sum out of data.foldable. So we're going to import that. And we want sum. Okay, cool. So it does work. So it's part of our, it's already part of our package list. That makes sense. And now we want to sum this entire thing. Yeah. Okay. So it does just work, thankfully, without us having to understand semi-rings and functors, which is kind of the promise of things like semi-rings and functors and stuff, that it will just kind of work for all types that follow a particular pattern or that match a particular category or whatever. But and luckily, like list of ints does, like a list of most stuff should follow that because it's a semi-ring or whatever. But we won't get into it now. It's a full day rabbit hole, that one, and I'm not even qualified to explain it. I'm qualified to hack through those things. So like if we look at this function, we're all convinced that this is a very nice to look at function. Hey, we're all very happy with how beautiful this thing looks, or do we have some complaints about this implementation? What do you guys think? You happy with this? Looks like Perl to me.
It's very inside out.
Yeah.
Sorry. I'm
Go
not sure I understand the \e to an arrow e. Like, what is the backslash e? I think I forgot that.
Sorry. Yeah. No, it's 100%. Let's explain that quickly. Yeah, that is confusing, but actually it's very simple. It's purely an anonymous function. So, and the format of it is, so when I'm writing a function, so it's like in JavaScript, I would write it equivalently like e points to something that does something, right? or in Python it would be lambda e, you know, e plus times 2 or something, right? So in Python, this is in JavaScript as an arrow function. Oh, actually, does it take a fat arrow? Sorry, it does take a fat arrow, I think, in JavaScript, right? Oh man, it takes a fat arrow in JavaScript. That kind of makes sense. So in Haskell and PureScript, you write exactly the same thing, but you start with the backslash, and then you put your parameters here. So if this was E, comma, F, it would look like that. And I think in Python, is it also comma? I think it is, right? If it took 2 parameters, in Haskell or PureScript, there's a space between there. So this backslash just represents like the start of the lambda function. And the idea of it is that it's meant to look like a lambda symbol. Do you know what I mean?
Yeah, so it just
Lambda
means
symbol.
apply this function on this value.
Yeah. So let's create a function inline. It's an inline function. Just quickly create a function here, which takes 1 parameter, E, and it returns E mod 2 equals 0. You know what I mean? So that's just, this is a function definition. It just has no name. It's not set to a variable or value. It's just a function inline, right? It's exactly like JavaScript. JavaScript would be the same. So I would go, if I wanted to do the same thing, I could go dot filter, and I would pass it an E mod 2 equals 0, right? So right there, there's a function being defined for the filter. Do you know what I mean?
Thanks, got it.
Yeah.
Thank you.
So the funny little backslash there is meant to look, when you see it, you must see this character actually, the little backslash, the lambda symbol, sorry. That's what it's meant to reflect. That's how I kind of remember it. It's like, oh, it's a lambda. Because like a lambda is an anonymous function, right? In Python, they actually call it lambda, which is great. In Haskell PureScript, they use the backslash instead of making you find the Unicode character for lambda. But you could probably, I don't know. No, let's another rabbit hole. Okay, so so you guys are completely happy that this is like totally portably beautiful code, very maintainable. I disagree. So let's like clean it up, and hopefully in the cleaning up of it, we can make it like look cooler, right? So I'll make here's another cool thing that's quite common is like you can use the apostrophe as like a little prime thingy. Like if you're making another function that's similar to the first one, just use the little prime. Just good. It's like a mathsy convention which has made its way into Haskell, but it's a valid character. So maybe what we would do here is like, so Miguel said, I think what you said, Miguel, is like stuff looks inside out, right?
Yeah, you like to get a good idea of what's happening. You're reading it from the inside of the function more as you're working your way out. It's like you're first doing you're taking the list, you're passing it to your filter, you're getting the filter, then you're taking the sum. Versus like 100%. You read this in object oriented. It's like, oh, I'm doing a sum of a filter, and you're like, hold on, wait, that's wrong.
Yeah, exactly. So like I 1000% agree with that. Like code like this for me is horrible because you can't read it. So like fundamentally, like what happens first when you look at this? You go, well, I don't know what happens first. Like, but what does happen first is the filter runs first, right? And then the sum happens after that. And it's just very hard to deal with. Like imagine if you had 3 or 4 or 5 things that it was going to filter, then toString, and then drop characters, and then sum them or whatever, right? It's like it's going to just keeps expanding on this side. So if I want to A all these things, I have to bracket like that. Then if I want to B all these things, I've got to bracket like that, right? And then I want to C all these things, and I'm like reading it inside out. So the order, it actually starts here somewhere, then it does that, then it does that, then that, then that. And that's like, I just think from although it's absolutely correct, it's just very difficult to read. So that's a cool thing. Let's flip the order around first of all so that it reads a bit better. So in PureScript and in Haskell, you've got 2 cool ways of doing this. So actually the first complaint that I have here is this bracket and that bracket there, because if I drop it, I don't know actually if I drop it. Yeah, it gets confusing now because now the compiler goes, but like, hang on a minute. So you're calling sum, the first parameter is filter, which is totally valid because you can pass a function as an argument to something else. Its second parameter is this, and it's like probably. So the error is going to be something weird, like could not match type function int with type list. It's like confused because I think the compiler is saying, well, you've given me a filter and this thing, and it's done some weird like partial application of shit, and it's like the error is just broken. And so like quite clearly it's like, no, sum takes one thing, which is like the answer there. So we bracketed it to help it. There is a better way of doing this without adding brackets, is we can use the dollar character. So dollar in PureScript Haskell is what it is, if we look at it, if we go and zoom into it, we will see first of all that it's got the lowest precedence, and it's a bind of apply. So apply just means invoke. So if you go apply, if you call apply, it'll just invoke it. So it just means execute whatever it is on the right, just execute it. But interestingly, what it's done is it's given it the lowest precedence. So that means that what dollar becomes is it almost becomes the separator to say the thing on the left of dollar must be invoked last. Like that is the last. So that tells the compiler, oh, so when I look at sum actually, like it comes the last, it comes the latest, the latest. So it means it will resolve everything on the right effectively first, and then pass that to the function on the left. Does that kind of make sense? It may not have to make too much sense, but effectively that's what dollar does. Is it just say it's a way of saying the bracket from here goes all the way to the end of the thing on the right, because it's like resolve everything on the right of dollar before you think about giving it to the thing on the left. Because remember, it's an infix function. So dollar effectively says, dollar says, takes two parameters, the thing on the left, the thing on the right, and it says, hey, the thing on the left must be invoked, but with the thing on the right completely bracketed. Does that make sense? I mean, that doesn't probably make sense, but like conceptually, that's what it's doing. Yeah? Yes, happy, no, happy, questions, no, yes, no? You're allowed to ask dumb questions, guys. I know that you've not seen a language like this before. This for me was like, what the hell is going on? Sorry, I interrupted.
I'm able to follow. So
you got it.
I'll see when I have to write one myself.
Yeah. Okay, so dollar, did you have something, Matt? I think I interrupted you.
No, I just said I think I get it.
Okay, yeah. So it's a weird one, and you're going to see this dollar everywhere. But effectively, when you see dollar, my trick is to go, when I see dollar in my head, open a bracket immediately, and then all the way to the end of the thing on the other side of the dollar is the closed bracket. That's effectively what it's. Dollar is saying, open a bracket here and close that bracket right at the end. Like at the end. Like resolve everything on this left, on the right side of this before you give it to the left. That's all it's doing. It's very common. It's still, however, it doesn't solve our inside out problem though. It does solve our like nasty bracket problem. Yeah.
Tom, I have a question. You wanted to do an A of sum. Could you go A dollar sum dollar filter? Can you like chain them like that?
Yes, totally. Yeah, of course. So if you wanted to, exactly. So if you're saying you wanted to call A with the result of all those sums, right? That's what you're saying. Yeah, you would you would just put another dollar. So that just says, so when the compiler reads this, he starts here and he goes, oh, you want to do A. What am I going to pass to A? Oh, dollar. So everything on this side. And then it goes, well, what am I going to do there? So I'm going to do sum. Okay, cool. Sum of what? Oh, everything on this side. So then it will resolve that first. Pass that to sum. Pass the result of sum into A. So that's pretty cool. It's just a way of like saying, but it's still going to resolve right to left. Do you know what I mean?
Yeah, makes sense.
You're 100% right. So you'll see this a lot. So it's kind of like I'm pipelining. I'm starting to think about pipelining, but they're like left direction they're pipelines that resolve backwards still, right to left. So still, I'm not a huge fan of this kind of stuff. It's certainly not for this particular use case, because it's like, no, we've got like ordered, we've got a set of operations that we kind of, the order is actually quite interesting. The filter, then the sum, then the A. Do you know what I mean? Happy?
Happy on my side. I just want to maybe build on the question. What Matt asked actually sparked the question on my side. If you had a second parameter that wasn't meant to be included in, well, it's meant to be included in your first method, or one, say it's meant to be included with the A, but you don't want it included with the filter. I'm assuming you have to.
Yeah. So you're saying if
the
A
order
took.
Yeah.
So if this was the first parameter to A, but there was a second parameter to A, like you wanted to also give it X or something. Yeah, totally. Yeah, exactly. So that
possible, or would that mess up?
No, this is very confusing now, because like if that X was meant to be the second parameter of A, it's not going to work, right? Because the dollar is going to say, wait a minute, when I resolve this thing, I need to resolve everything over here. So it's going to run filter effectively with 1, 2, 3 parameters is what it's going to say, and it's going to be broken. Okay, so it doesn't know about A, first of all. So we'll get into how you should do this better, but like in this scenario, if that was exactly what you were trying to do, you would absolutely have to bracket that to there. Do you know what I mean? Because then A that's its first parameter, and that's its second parameter. But there's probably better ways of doing this, which we'll get into. But yeah, you're quite right. You can absolutely, dollar is not the answer to all things. It just resolves everything on the right. So it's useful in a lot of cases. Certainly we're going to open bracket and close bracket right at the end. So there's an inverse of this, which is pretty cool, which is so this one, remember, so dollar looks like this, dollar first, I'm going to use first and second. Does that make sense? Or left and right? Executes left with like a bracketed right. So whatever gets given to it, let me put the dollar in the middle just for like clarity. So when we've got something on the left of dollar, something on the right of dollar, it's going to effectively invoke L, the thing on the left, with the thing on the right bracketed, right? I mean, this is not code. This is like concept. So there's the opposite of this, which is L pound R equals, let me think, it's R with L. Bracketing, I'm not sure. I think it's just like that, actually. It doesn't necessarily bracket stuff. Oh, maybe it's, would it be? Don't know about the brackets. Yeah, it looks like that. Yeah, the bracketing is fine. We can bracket. It's a bit weird because it's on the left. So the opposite of dollar is pound or hash, whatever you want to call it, pound sign. And it effectively just flips this around. So let's actually do that. So that's quite cool, actually. So we know that happens first, the filter, and then we know that the pound happens next, and we can do that, sum. So that's cool, right? That's like already has fixed that. Miguel's ordering back to front reading through this thing. And like maybe a better way from a formatting perspective is I would normally chain them, because if it's sum and then you want to call A on that, you would do that. And if you wanted to call B on that, you would do that, right? So it's like, it reads a bit better. Oh, okay, so we want to filter these lists of ints. We want to sum them, A then them, B them, yeah? Are you guys happy with that? Just jump in with questions. I'm going to assume happiness, but like if you're not, please like stop.
I'm happy that it makes. It's just unfortunate that it's a pound, because my brain reads that as a comment, because I'm so used to reading Python. So in my head, line 23 is a comment, but that's just a personal problem. It makes perfect sense.
There's going to be a lot of things in this kind of language that you're going to have personal problems with. Believe me. So syntactically, like Haskell is and therefore PureScript is very different to a lot of language. It's much more like math, like it kind of puts like maths into its like syntax. It's syntactically mathsy, you know what I mean? Not a lot of keywords and stuff like that. But you get used to it. I mean, comment we saw is like this. Is this like the SQL way? I think it's a SQL way of commenting. And I think in PureScript there's something, I think if you put this like pipe there, it means like it'll document it or something. It'll become like a hovering doc. Maybe not. I don't know. If I go log, write messages, tfunc, no, doesn't like it. I don't know. Something to do with this pipe. I can kind of remember. Maybe it's a double pipe. I don't know. Okay, but you'll get used to that. Interestingly, like there's still something funky going on here that we can resolve this. So let me just make another one. I'm gonna make a whole bunch of another ones. Like the way I would maybe do this is actually like this. Does that kind of make sense?
Yeah, I think that's how I would probably want to write it as well. Take the list and pass it into the function, which passes it into something else.
Yeah, exactly. Yeah. So it could. There's a rabbit hole inside here, though. There is a rabbit hole because it's like, well, what the hell is this? Do you know what I mean? Like, what is that? It's like, how is the compiler okay with this? Because it's like, we're saying filter, but we've only given it one parameter. Are we allowed to give functions one parameter?
Yeah, probably not. I wonder, has it partially applied it under the hood and is waiting for its list?
Well, the question is, can we give it only one parameter? And the answer is yes, we can, right? We can call filter with only its first parameter. Right? And what does that do? That returns a function that needs one more parameter, which is a list of ints, right? Oh, look, we give that to it next. You know what I mean? So, like, when you break this down, remember when we were talking about currying and partial application, we were going like, but it's daft. Like, why, you know, it's like not incredibly useful and it seems very complicated, but it's exactly for stuff like this. So it's to say, absolutely, like, we're going to be passing you a parameter a bit later, you know, when stuff resolves later. But the compiler can still like type check this thing, no problem, because it goes, oh, this what you've done here, because we can take this as a function y or something, or as a variable y, and we can say, well, what is it? If we hover over y, I'm hoping we can. Oh, we can't, because it's a moron. Where do I get filter from? Maybe I can paste this up here. I can say, what is the type of y? And it's like, oh, it's a function that when given a list of int will return us a list of int. It's like, oh, yeah, that's cool, because filter already got given its parameter 1. So y itself is a whole new thing, a whole new function, which is effectively that. You know what I mean? So it's like, so we can start to factor this out then with that interesting. Is everyone comfortable with that so far? Matt is comfortable. Matt has written some Elm, so he's okay with some of this daft shit. What about the rest of you guys?
Isn't it going the other way? Like, I mean, that pound sign is making it go to the right. Yeah, maybe I'm not following that properly.
Yeah. So what does pound do? Let me get rid of the sum, because that is going to confuse things for now, and we'll just deal with that, right? So what does pound do? Pound says, what is it? Whatever's on the left side of the pound operator gets given. So gets given as the next parameter to the thing on the right.
Okay. Yeah.
Does
Sorry.
that make sense?
Okay.
Remember that. So it was like, yeah. So it's like you can absolutely bracket whatever's on the right, and you can say, well, that thing with the effectively this, I mean, it like will resolve to this, that thing on the right. You know, which is what we had actually. You know, that's exactly what we had. We had filter with the method with the list. We've just moved the list over to the left side, and so it now feels more like pipey. I take the list and I pipe it into the filter function, and then I pipe it into the sum function. And the pipe is executed by just saying, hey, whatever's on the left, I'll just give as the next parameter to the thing on the right. And as it resolves, I'll give that as the next parameter to the thing on the right. And I say next parameter, ideally it should be the last parameter, the final parameter. So that final parameter keeps getting fulfilled. You know what I mean?
Tom, could you rewrite that? Sorry.
Yeah.
Could you rewrite that top one, line 17, to be like sum next line dollar filter next line dollar list?
Yeah, totally. Yeah, exactly. Yeah, absolutely. So I should have kept that. I'll make a prime because that is a valid way of doing it. So you're saying filter with, what did you say? With dollar, oh no, so sorry, it would be sum dollar, then let me just new line it, with filter, and then with dollar list.
Dollar list, yeah.
Oh, that's a good question. I think you can. Yeah, I don't see anything wrong with that. Yeah, because it will just resolve that. It's kind of already resolved, right?
Yeah.
Pass it there. Yeah. So exactly. So this is exactly the inverse of our cooler one, which I've now broken. I'll take that one, which is prime. I'm doing this so that the compiler can keep up with us. So we take that one. Okay, so that's Paul's version. And we're going to say, oh, okay, wait, we want to use pounds, and we want to invert this so that list event happens first, then is pounded into the filter, which is then pounded into the sum. Because that's actually the order that things resolve. Things don't resolve in this order. They resolve back to front here, right?
Yeah.
Now the ordering is better. Yeah, look, the compiler's happy with that.
I don't hate that one with the sum
This
first.
one.
Yeah,
Yeah,
so if I read
yeah,
the
100%.
function, I'm like, okay, cool, it's going to return a sum.
Yeah.
And it's like a sum of what?
The S community agrees with you. They prefer this.
Oh.
Yeah. Absolutely. So I mean, it's purely a style. It's like, do you prefer like a pipeline? Because this is like, I would call this more like pipeline programming. You know, it feels more pipey. The order of things is like more English. So when I read through this, I go list of ints that are filtered and then are summed. You know, it in the order of things makes sense here. Whereas this, you have to read backwards. You have to say list of ints filtered and then summed. Or you could say it's the sum of the filtered lists, I suppose. You know, you'd have to use the word of here a lot. But absolutely, totally equivalent. And the pound and the dollar allows you to like structure this nicely. Yeah. Sure. I think this is like, I think when you feel your way through this kind of programming, you go, oh, and then eventually you're like, oh, actually, it's quite neat and tidy. It is quite a nice way of making things neat.
So in this world, is that like the tabs versus spaces fight? Like, do you define it in using pounds or dollars?
So this is definitely an indent sensitive language. Absolutely. So if I back tab that will definitely cause me an error. So like indentation is important. Yeah. There's no, yeah. So then instead of you being forced to open and close brackets to deal with like the order of resolution, you can use these cool operators to, you're still telling it in what order things resolve, but the cool thing is you don't have to close them because it just says everything till the end, the end. You know what I mean? Which actually I think is quite nice, quite neat. I think it's like pretty cool. It's kind of just less shit, less format crap. However, okay, so let's stick with. I mean, I think these are both cool. They're both like nice equivalent thingies. And I think we're okay with them. I know we may struggle a bit, but I think a little bit of practice here will make these things feel more comfortable. But if I still look at them, so either version, we can still factor this out a little bit nicer, right? And let's just do that. I know it's like maybe a bit nutty, but let's just do it because we'll learn something about the language. So there's one very important concept here is that like everything is an expression. Everything is an expression. Everything. So in C# or Java or like regular ass languages, you do have expressions for sure, but you also have these things called statements. Do you know what I mean? And a statement, how is a statement different to an expression? Does anyone know? This one's for super points. It means that you were listening in ComSci class, if you did ComSci.
I can try.
Go.
I think an expression resolves to something, and a statement contains expressions.
Okay. Yeah. Well, they don't have to, right? But they could. They could. Quite right. Yeah. So you like 1,000%. An expression returns an expression returns a value. Like an expression has got a value associated with it. Because when I resolve it, I get a value. Whereas a statement just says, hey, do this, do this, do this, and it doesn't actually have a value associated with it, which is interesting. Because it's maybe we're getting mathsy here, but like 1 plus 2, does that have a value? What is its value? This
You
as
can
a
resolve that to 3.
yeah. I don't even have to resolve it, right? It already has the value 3. It does, like if we take time out of this thing, 1 plus 2 equals 3. It's like it always does. It always has. It's not like it would ever be anything other than that, right? It always has the value of 1. It's like very pure. 1 plus 2 fucking doesn't matter. Take this thing to Mars, take it to, like, think about it yesterday, think about it tomorrow. What's its value? It's 3. It's 3. Doesn't matter what you think. There's nothing here that would alter that ever in time, space, maybe in a parallel universe where the laws of maths change, but this thing is universally a 3. Doesn't matter. Like we don't even have to calculate it. We know what it is. So that's quite interesting. So that's an expression, right? 1 plus 2 is an expression. But a statement is like, statement would be like, maybe like, how could we make this thing a statement? A statement is like, it's like a set of instructions to do stuff, but they don't, like in C# or whatever, like you have a for. I don't know how you do a for. For var I equals 1, I less than 10, plus I, right? Does this return us a value? Like, is this an expression?
No.
Or is this a statement? It's a statement, right? I can't go, because here I can say, well, x is the value of 1 plus 2. So I can't actually give you like an analog to this in PureScript. But anyway, I can't go like in C# var x equals and have x be set to some value from a for loop. Do you agree?
Yes.
Yeah.
Well, not in that way, but you could write that for loop as an expression.
Yeah, like with a for each or something, right?
Yeah.
Yeah. But I'm just saying this is an example of a statement. Another example of a statement is like a switch. In fact, it's called the switch statement, right? It also doesn't return a value. So I can't set something to the result of that. So what you're going to find in pure functional languages is there's no such thing as a statement. Absolutely everything is an expression. So where you find things that may look like fors or switches, so there's even the if statement in, I mean, this is the like prime example. Is like, why isn't if an expression actually? Why isn't it? I'm actually asking, I don't know why it isn't, because I think it should be. Like if should absolutely return the value of what it resolves to, because and I'll tell you why it isn't an expression. It's because else is an optional concept in a lot of languages. So like the problem is in a type safe language, I could return, if Bob return 5, right? So what is the value now? What is the type of x? In C#, it's like, well, if Bob is true, then it's an int. And if Bob isn't true, then what is it? It's like, ooh, I don't know. We don't know what type it is actually. And because the else is optional, that means if needs to be a statement. Can't be an expression because it doesn't always resolve to something. However, if you had a language where you said else is always mandatory, you must always put in the else, then you could enforce that x is an int, because it's like, well, if Bob, it's 5, and if it isn't Bob, then it's 10. It would then be a problem to say, well, return hello, because it's like, well, int is not a string. So x can't be an int and a string at the same time. Well, the compiler can't, it wouldn't know how to, what type x is. And actually, like in good languages, so Scala, for example, does this. If has a mandatory else. I think F# actually does too, maybe. If has a mandatory else, and if is an expression, which is really cool, because then you don't need that funny ternary operator. You can start to say stuff like, you wouldn't have the return in here, but like if becomes actually quite useful because it can return something. Do you know what I mean? Anyway, that's a little rabbit hole. We found another rabbit hole. So everything is an expression. So that means so here's an interesting side effect of that problem though, is that, so say I wanted to like create this thing earlier, right? I wanted to go like, oh, actually, I've got the is. So if I think about this, this is like a function called is even, right? Do you know what I mean? So like I could create a function here, is even, sorry, and I could do that. Yes, and now I could call is even 10, and it would say yes. Is even 9? No, it isn't. Okay, happy with that? So it's like, oh, cool, yeah, that's a cool function, right? So like I want to set that to a thing earlier, like make a little variable kind of thing, and then I want to call that here, and then my code looks a little bit nicer, right? So it's like I've made a little helper function, so I can make my function cooler, right? If I save this now, it goes, oh, but wait a minute, there's issues here. It's like unparsable, and it's because you can really only have one equals in your function. Your function has to do one thing and one thing only. Yeah, and it's like it doesn't know about about statements. This now has made this a statement. Actually, if I think about this, it's like what I'm telling this function is like, oh, first you must do this, then you must do this. There's no such thing in a pure functional language of like this, then that. There's no such thing. It's like the way it orders the things that must execute is just through resolving. So as it's resolving the expression, it will execute things in the correct order, which we've already seen with the dollar and pound. There's no way of telling it, oh yeah, do this thing, resolve that whole thing, and then do this thing next. It's like we don't have the power to tell the compiler in what order these things must run as like from a statement, top to bottom style, which can be pretty daft, right? So you go, oh, okay. So like equals must have one thing on the right side. Before when we had, so here we've got this thing, it's like this is still valid because there's only one thing on the left, which is this thing. It's that, which is one thing actually. It's one thing made up of a whole bunch of little things, but it's only one thing. Whereas now what we've done here is we've actually got two things. We've said, do this, then clear your brain, and then do this. Do you know what I mean? Does that make any sense? I'll tell you how we solve this. It's like not a big deal, but it's quite a big understanding to go like, I can't like do multiple things in order. And the answer is no, you can't. Like the compiler is going to resolve things in the way that things get resolved. Weird? Not weird. Comments. Hate. Come on, Drickers, you got to hate this, surely.
No, I'm very comfortable with that. I'm trying to understand why you would want to do line 24 and not just have that as like a separate function. No, line 24 the is even, and not just have that as like.
No, totally. No, so you totally could do that, of course. Yeah, of course. So we could, I mean, that's absolutely one way to do it. Absolutely. So that would totally work. We could just put that up there and we create a whole new function. So then we stick to our rule, which is like, okay, cool, this function has only one thing that it does. It does the sum of these things. And then while it's resolving, it goes, oh, yes, I need to go and resolve that. And that's cool. And so we haven't told it any ordering, how things are ordered. The compiler is figuring out the order. Absolutely, you could. So what I'm trying to say is like there are some cases. So is even's a bad example because is even might be useful. But sometimes when you're trying to break up a function, you just want to break it up, and some of those things are not first class things. Like it's a helper only in the context of this function. That was kind of what I was trying to get to. Is like I don't want to expose it to the high level. You know what I mean? I want it just exposed inside this function because it's maybe it's very specific to this function. Do you know what I mean? Like it could even be something like the length of this list of ints, right? Maybe at some point I want to go length of list because I use it in a few places, and so I don't want to you know, like I want like a variable in here, not necessarily splattered in there. You know what I mean? Like the length or
That's
something.
maybe a scoping issue. Like, because
Oh,
what that you're saying is that you can't scope that method to just that function.
Yes. That's what. Yeah, sorry. Scope is the right. Yeah, that's why I want it only scoped to this function. Like I want to create like a variable. I'm doing some earlier computation and I'm going to use it in a few different places later. I don't want to like repeat that same code over and over and over. So maybe is even's not the best example of it. I mean, as you point out. So yes, scoping. So how would I do this is the question. And there's a cool syntax called let syntax. So you can totally do this. You go let, you create all your variables up here, and you go in this expression. So this becomes, again, a single expression. So let is a single expression where the things between let and in get created in this result down there. Well, in that single expression down there. So these things, that will be resolved, and these things will be within the scope of that resolution, if that makes sense. Do you know what I mean? And it's still and now it feels like I could go x equals 10 or whatever, and name equals Drickus, and that's okay. It's like I can create some variables up here. I could even say like, I could even invoke these functions. So I could say, you know, x 10 is even there, and then I could use that down here or up there. Does that kind of make sense? So this kind of feels now more like a multi-line, or it's a way of factoring common things up within the scope of where you are.
Tom, and when you used x there as a value name, it seemed like the compiler was happy with that, or the IDE.
Yeah, that part.
So yeah, if you make that x and you've got x defined up at line 12,
oh yeah,
it seemed like it was happy because it's
totally.
It is scoped to that function.
It is scoped to that function, so it would shadow it.
Okay.
Would be my guess. Yeah, it's a good question. So that x there would be, although when I hover it over it now, it says it's list of int, which it clearly isn't. So that's that one. But here I'm redefining it. So if I had to go, like let's go y equals x or something. I don't know if this is still going to be list of int. Still thinks that's a list of int. Do I have other errors elsewhere? Yes, I probably do. Yeah, here. Let me just kill that one. Yeah, there. So there's a warning. Name x was shadowed. Yeah, so it will shadow it. So it's like it's telling you, hey, like there is another x. This one, I mean, this would happen in any language, right? You're introducing a new variable which should shadow the more global one, and that's a good warning. But very often, I mean, I'm fine with that. Like I may want to shadow it, absolutely. So it comes out as a warning. So that's fine, as long as it was not at the same scope, right? That x is also equal to 10. That would be a problem. It's like multiple declarations. So you can shadow things in subscopes. That's okay, not in the same scope.
Okay, that's cool.
Yeah. So that syntax kind of is your escape hatch back to the old multi-line way, or it's a way of organizing your function in like more space. Because if you think your limitation of like I'm defining a function and I can only have one thing that I do is absolutely right. But like I can break that one thing and I can do a lot with that one thing. I mean, I can do everything with that one thing. And let syntax allows you to do that quite cleanly. There is an operator. There is the opposite of let, which I never use. It's called when, I think. Is it? No. Let versus, can't remember. There is the opposite of let. I think it was where or when or something. Let's see. Let and where. Oh, it's called where. Where. Oh, yeah. So it's the opposite. So it would be like you take that thing. Sorry, this is the last thing. You guys can drop off if you need to. Would be where. you would take this thing, you take your function, what you're doing, and you put the where like there. Betty, hey? Or you could, I suppose you could backtick that where. So here it's just the opposite. So here it's like you're defining the things up front in your expression, or it's like you want to resolve the expression where these things are being used. They're totally equivalent.
This is pretty crazy stuff, to be honest.
Yeah, it is.
You can totally make yourself irreplaceable if you learn PureScript.
And Haskell, yeah, for sure.
But,
yeah. But
Love it.
I mean,
I'm
you know,
actually
whether
loving this so much.
the decision as to whether you use this for production code is very different to whether you should learn this, because what you can learn through this kind of thing is like, oh, this is a constraint that is like, you go like, but why is there this constraint? And it's like, no, this is a pure language. There's no such thing as you telling the computer in what order things happen. You can ordering is not pure. Like in maths, there's no, you don't, when you're writing out like a I don't know, like an equation or whatever, you don't specify the order of things. You don't, it's not a computation that you're trying to achieve. It's just you're writing out the equation, right? And of course, you as a human, you may like compute in order to find the answer. That's exactly the same with Haskell and PureScript. Is you're just the mathematician here defining the equation. The computer is going to use its ability to resolve this to the answers that you need. You don't have to tell the computer how to do that. Guess what? Computers are pretty good at that. Computers know how to compute shit. You don't need to tell them how. You just define the problem statement. And so everything as an expression and everything as an expression makes a whole lot of sense, because what you're saying is like, actually, it's not that important as to like the order that things resolve, as long as they fucking resolve, right?
Yep.
When I need them. And so the beautiful thing about Haskell, this is another tiny rabbit hole, is the interesting thing about where you can go with that. Once you have a language that does that and enforces that, you can make that language something called lazy. So you can make that runtime lazy, where it says, I'll only resolve the stuff that I actually need to. I don't need to resolve things that, because I could even do, you can do batty shit. Like you can say, hey, X is a list from 1 to infinity. You know, I'm not saying this is how you can do it, but you can in Haskell, you can define this. You can do this in Python, of course, you've got generators and stuff like that. But in Haskell, you can have an array, which has got an infinite number of elements in it. And you go, okay. So a runtime that goes, yeah, but you've got to tell me how to compute this, is going to get completely stuck on this, because it's just going to go forever. It's going to just like create the next element, like create, and just get stuck here. Whereas a lazy language like Haskell goes, oh, and that's fine. I got an array which has got an infinite number of elements. I'll only resolve them if you need them. You know what I mean? So it can become lazy, which is like you can define shit like this. So you can say, well, y is x, but like mapped to e plus 1. And you can say, yeah. So now x is every element in x plus 1 of an infinite list. It's like, okay. Like, so like in Python would just die here, right? Because it would just say, oh, no problem. I know how to do map. I'll get the next element out of the generator. Dung, 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 forever. Get stuck here. In Haskell, you can totally write this, no problem. Because it'll say, well, you never use y. Because later on, like, oh, you don't use y, no problem. Your program doesn't need, I never resolve anything in y. I don't do that. Of course, if I did, I could say, hey, get me like, get the 10th element of y, and then it'll go, oh, okay, fine, I'll go and do that for you. And then it'll run it only up to the 10th element, because it's lazy.
Yeah, that's what I want to ask. So you could use it.
Yeah.
You don't have to utilize the whole space. That's fucking awesome. That's cool, because that's like mathematically correct. Like that's
absolutely mathematically correct. Yeah, 100%.
Correct statement.
So this is like lazy, effectively, is the ability to do this. I don't know, infinity, you know. I mean, it's not valid, but yeah, absolutely. So Haskell is 100% uses the language of maths at its core.
I love that.
That's
It's really
crazy.
cool.
But this is like, we'll get there. All right, guys.
It's
Have
very
a great,
cool.
great Friday and a great weekend.
Thanks,
And
Tom.
I think we're meeting again on Monday. Was it Monday? I can't remember. I'll write a message. Cheers, dudes.
See, I've got a ton of homework to do this weekend to catch up.
Well, I put the first video on, Paul, for you.
Yeah,
You can
I
watch
saw.
that one.
Thanks.
Okay.
Awesome.
Cheers, dudes.
Thanks, Tom.
Ciao.
Cheers, guys.
Ciao. Ciao.
Cheers.
Thanks,
Bye.
Tom.
Cheers.